It's amazing just the difference it makes when you design for everyone, how much better a product turns out. That as well guides what I do when I try to develop new products. My name's Chris Carell, and I'm a hardware engineer at Circuit Scribe. I work mainly on developing new modules and content. I used to work at the Texas School for the Blind as first a teaching assistant and then a teacher. I taught high school math. We went to the School for the Blind to beta test some new features I've been working on, adapting the modules to all different learners. I think it's really important to get feedback about what works and what doesn't work, because I use the modules in one way because I learn in one way, but there's just so many different types of learning, so many different students out there. It was a generally positive reception for sure. And I just love going back up there and teaching again. It's a lot of fun. When I was teaching at the School for the Blind, having a student with a visual impairment navigate a breadboard was not an easy task. To count out the holes with a wire to probe the holes, it takes a lot of tactile skill. Opening different learning means of electronics is really important, and what I find really exciting about Circuit Scribe. We started with the most basic circuit, which is just a 9-volt battery and a module, and then we moved on to making a paper switch as well as series and parallel circuits. I just kind of brought everything I had and saw what took hold. So it first started with the solder bumps. So it's important to know which way your modules are oriented in your circuit, because if they're turned around, your circuit might not work. I thought, how can we add something to the current module ecosystem that is easy to manufacture and helps tactile learners? We went with the solder bumps as opposed to a different board shape. Kind of seemed like a no-brainer. It used to be, line up plus to plus on the modules. But for some students that's still confusing them, and so when I said line up the bump to the bump, everything just kind of clicked, and you get your buzzer, you get your light, and just seeing the student's face light up when they make their first circuit is really cool. They were able to make something happen in the physical world. It's amazing just like the difference this makes, and not only like students who are visually impaired, but students that are tactile learners. Solder bumps definitely win. I'm really excited about the code module. We're using Arduino, as well as Arduino has come out with the command line tools. Allows you to program in Arduino in an all text environment so a screen reader can use it, which is super exciting. I'm always thinking about my students and back at the school and how they would benefit from it and learn from it. Another module I'm excited about is the vibration module. So just having a vibration motor on a module to get haptic feedback. I was thinking, like, how could a teacher of the visually impaired with limited resources, develop materials for their students? Actually putting pen on paper is, a big part of Circuit Scribe, drawing your circuits. First started with, stencils, especially with students that are new to learning tactile graphics. This is the first iteration. It's just like cut out X-Acto knife, simple, just your first circuit. We had a Cricut plotter, so this is just an embossed lines, and there's this really cool stuff called swell paper that you print on it and you send it through a heating element, and then the lines all raise up. Just kind of cleaning up the graphics, making them more simple for students that are visually impaired and use large print. Using the white stencil on a black background can be helpful for students. Just contrast helps. It's cool to see how different learners use adaptations. I am just amazed at the amount that things like deep learning and artificial intelligence have opened up for accessibility, especially with visual recognition systems, and just being able to get an app on your phone that, you know, takes a picture of something and then reads a description to you is so cool. My hope is that every student, regardless of their background, regardless of, you know, anything, is able to learn to the best of their ability. My hope is that, you know, as technology gets better and better, that students are able to learn in any method that they learn best. I mean, I feel that inclusion is important in the classroom because it's about learning about everyone. It's about being open and tolerant of, you know, people regardless of who they are and their upbringing, and, you know, maybe they're born with an impairment or a disability. It's important that students learn about that from a young age and are open to it. Students benefit a lot from learning from each other. There's this idea that the teacher is, you know, the sole information source in the classroom, but that's not true. Students learn way more from their peers than they do from their teachers. And just being open to all different learners and just all different, you know, backgrounds enriches that atmosphere of learning. The important thing here is testing as many different things, because there's just so many different learners out there, and just working and trying to find something that's universal isn't always going to work, so you just kind of have to have all the tools in your arsenal. It's important to do your best to design for everyone, and, you know, you have adaptations and you have different resources for different learners. I really just want to see students have all the opportunities that, you know, I had growing up. Everyone is entitled to an education that best serves them.
You got it? Conductive.
Yes!